Hello everyone, I am Dr. Thiazole. Today in this video we are going to learn about thiazole, structure, synthesis and chemical properties, and of course application, but we are not focusing this time on applications. So look at here the properties. First, if you are talking about the aromaticity, so we have the nitrogen and sulfur. This nitrogen is like pyridine nitrogens. Why we are talking about the pyridine and pyrrole like nitrogens? Because their properties are different and they are opposite to each other. In case concerning to properties. So sulfur, you can see this thiophene like sulfur. Now the important things here, you can look what is the focusing point here. Position of sulfur and nitrogens. Here sulfur is getting position 1, nitrogen 3, and of course we have remaining 3 position. You can look at 2, 4th and 5th for the reaction purpose. Now molecular orbital, you can see the sp2 hybridized orbital and sp2 hybridized orbital on nitrogen and sulfur, and unhybridized p orbital. So thiazole have 3 carbon, 1 nitrogen, 1 sulfur, you already seen. sp2 hybridized, you know. Each ring atom also contains unhybridized p orbital, and that is perpendicular to the plane of sigma bond. You know, p orbitals are parallel to each other, so overlapping between p orbital is possible. The total number of non-bonding electrons are 6. So the resonance of 6 electrons follow the Haeckel's rule, so it is aromatic. Now synthesis, Gabriel synthesis. You can see the condensations. After condensations, you are getting this thiazole ring. So condensations of acyl aminocarbonyl. Acyl aminocarbonyl. Now you know the carbonyl, you know the acyl, you know the amino groups. So focus on term also. Then it will be clear to you what's actually this reaction. So this compound in presence of phosphorus pentasulfide. Now the mechanism, you can look at the mechanisms of Gabriel synthesis, how the bond formations between carbon double and the carbon double bond sulfur, this bond shifting for the formations of 5-member ring, and then shifting of pi electrons towards the oxygens. Then you are getting this second structure, and finally after dehydration you are getting your thiazoles. Now another hence thiazole synthesis from alpha hydroxycarbonyl components. You can see thiamide and see the alpha haloketones, both compound you know very well. You have to just practice. This is the substituted thiazoles. This is the mechanisms. Write it down and go through the step by step, how carbon chlorine will break, how carbon sulfur pi bond approaching for formation of bonds, and how lone pair of nitrogen forming double bonds like amine. So SN2 type reactions, you can see H plus is approaching oxygen to mode activates for the nucleophilic attack on carbon, and then cyclization again. You can see there is a hydrogen NOH. Now here dehydration occurs, E2 type reaction means formation of double bonds, and this is your final tri-substituted thiazole. Now from an thiocyanate salt, you can see the dipolar thiocyanate salt, it reacts with chloroacetone forming 2-hydroxy-4-methyl thiazole. Now think about the creations, electrophilic addition to nitrogen, of course protonations, because nitrogen is present, so it is showing basic properties, and Again, beautiful things, it is resonance stabilized thiazolium cation, automatically stability are coming or stability will regain with the resonance. In alkylations, electrophilic substitution to carbon. Now you have the fourth and fifth favorite positions. Electron releasing groups add 2 positions if it is there. So nitration, you can see 2 bromo, and you can see the nitrations of the 2 product if you have different substrate like 2-methyl thiazoles. So 2-methyl 5-nitrothiazoles and 2-methyl 4-nitrothiazoles. Now you can see the electrophilic substitution to carbon. Sulfonations, thiazole 5-sulfonic acid. Then again you have to think about the position of 5. You think about the oleum, mercury, 215 reaction conditions. You know at this state everything, you have just practice it. 2-methyl thiazoles, it give 2-methyl 5-bromothiazoles. Now you can see the 2 aminothiazoles react with in these conditions, Na2HCl minus 5 degrees Celsius, you will get thiazole 2-diazonium, and again cuprous chloride, it will give 2 chlorothiazoles. Now medicinal uses, you know a lot of medicinal uses of all heterocyclic compound. So I am not going to in details of thiazole in medicinal application, because your work is you have to know the synthesis, some important properties like electrophilic, nucleophilic of chemical reaction. And of course you have one papers where medicinal chemistry you will learn this ring is always present in like the H2 receptor blocker, nizatidine and famotidine, like this. So friends, I hope this video will be helpful to you. If you like this